So today we are just going to give you introduction to OOPS concept, and from Monday onwards we will start actual developing, right? So if you look at our syllabus, okay, so let me open. So the first two chapter are nothing but introduction chapter, right? So we will give you introduction to what is exactly OOPS, why we need OOPS, what is there before OOPS, right? What are the problem we face before OOPS, and how we resolve all such problems in OOPS, and what are the principle provided by OOPS that we will discuss. And then we will discuss class and object. We will discuss whether class and object are part of OOPS principle or not. Then what is class and what is object, right? How to create a class and how to create an object. So we will try to understand this concept by taking not a programmatic example, but taking different kind of a real-time example, so that you can understand exactly meaning of class and object and exact meaning of a OOPS concept. And from Monday onwards, we'll start actual developing, right? So we'll today what we'll discuss, you will get some basic idea, right? And all these things are going to be discussed from chapter 3 to 20, right? So you will see that I will discuss something called a shield, partial, operator overloading, polymorphism, interface, static, inheritance, abstraction, encapsulation. All these things, constructor, destructor, are going to be discussed in detail from Monday onwards. Today, we are just going to give basic introduction to object-oriented programming concept, and it is very important. See why? Because understanding the concept is important. Writing the program is not that important. Understanding the programming code, what you are writing, you have to understand the bit by bit. You have to understand statement by statement what each statement is doing, when that statement is executed, what is happening. If I am using a keyword class, if I am using keyword interface, right? If I am using public, private, protected, integer, whatever the things you are writing, each bit by bit you need to understand what is the meaning of that, right? So understanding the meaning is important. And writing the code, nobody in the world can write all the things by their own. They are copy pasting from internet or from others, right? But understanding the code is important. Okay, so let's start today's discussion regarding this first chapter, that is object-oriented programming concept or OOPS concept in CSharp. Then we will move to class and object, right? So is that clear? What is today's agenda?
Yes,
Okay, yes, sir.
Okay. So let us start the discussion. First of all, what is object? What is we are going to discuss? Morning. So OOPS is not a technique, right? OOPS is a technique, not a technology. What it means? First of all, the basic definition is that OOPS, which is commonly object-oriented, commonly known as object-oriented programming, or in shortcut, you can say OOPS is a technique, not a technology. Whenever I'm saying technology, means it provides some syntaxes, right? It provides some suggestion, it provides some syntaxes, or it provides some APIs which you can use to develop any application. But OOPS is not something which provide any syntaxes or APIs. What OOPS means, it provides some suggestions, right? What suggestion means, you can implement or you can use those suggestions while developing the application, so that you will get lots of benefit. What benefit we are going to get, that we will discuss. But for now, OOPS is not a technique. OOPS is a technique, not a technology. When I'm saying not a technology, means it doesn't provide any syntaxes or APIs, right? Syntaxes or APIs in the sense it doesn't provide. If you look at the C programming language, right, whatever the statement we have writing,
not able to hear.
yeah. Am I audible now, guys?
Yes,
Okay, so actually my internet.
you are audible. You are audible.
Sometimes it is breaking. Your voice is breaking sometimes.
The
Okay.
screen is not visible, sir.
Okay, wait for a few minutes. I'm sharing the screen. Now you can see my screen.
Yes, sir.
Okay. Okay. So
Yes,
actually,
we can see.
yeah, actually there is some slow internet in my location. That's why the problem I'm facing. Okay. So basically the first concept is OOPS is a technology. OOPS is a technique, not a technology. So we need to understand what is the meaning by a technology and what is the meaning by a technique. Technology means it provides some syntaxes, right? Syntaxes means if you look at the C programming language, again, I'm having some internet issues. Hello?
Yes, sir.
Am I audible? Yeah, still having some issue.
Yes.
You're audible.
Okay.
There is some lag, sir. Means you're audible. Sometimes it is breaking. Your voice is breaking.
Right. Okay. Okay, let me again explain this concept. Right. So, OOPS is a technique, not a technology. So, we need to understand these two terms very clearly. First of all, technology means it provides some syntaxes, it provides some APIs. So, in this case, you can see if you want to declare a method, then you have to follow this syntax. If you have to declare a class, you have to follow this syntax, right? And the syntax is the statement should be end by a semicolon. So these are nothing but your syntaxes, right? So OOPS doesn't provide any kind of syntaxes like this, right? So OOPS is not a technology, hence it doesn't provide any syntaxes like. Then what OOPS? OOPS is a technique. Techniques in the sense it provides some principles, you can say, and by using those principles we can develop our applications. If we develop our application by using the OOPS principle, then we will get a lot of benefit. What benefits we are going to get, that we will discuss in today's session. Is that clear? Hello?
Yes.
Okay. Still my internet is very slow. Okay. Now, before understanding OOPS concept, let us first understand how do we develop applications, right? So OOPS means object-oriented programming is a strategy or a technique that provides some principles for developing applications, or you can say for developing software. So it is a methodology. That means it is a method for developing applications. Like OOPS, we have other methodologies also existing in the market. What other methodologies are existing? Structured programming, you can say procedural programming, or you can say modular programming, right? These are other technologies, or you can say these are other techniques, or these are other methodologies which are exist along with OOPS, right? But nowadays, one of the well-known and famous style of object orientation is object-oriented programming, right? So apart from object-oriented programming, we have other programming methodologies as well existing in the market, like structural programming, procedural programming, modular programming, but those programming or those methodologies are not used that much nowadays. What methodologies nowadays is mostly used is object-oriented programming. So first of all, we need to understand why object-oriented programming and what are the problem with this modular or procedural programming, right? Nowadays, almost all the latest programming languages support object orientation. Object orientation means everything based on the object, right? And this object orientation is more related to the design of the software, and this deals with the internal design of the software, not the external, right? So nowadays, if you take any latest programming languages,
Not able to hear your voice.
yeah, I just mute. Okay, so now it's audible.
Yes, sir.
Yes,
Okay.
it is.
So nowadays, if you take any programming language, any latest programming languages, all the latest programming languages are based on object-oriented concept only, right? If you take the example of Python, if you take the example of Abstract, right? If the take example of C#, if you take the example of Java, all these programming languages are based on object orientation. Object orientation means the base. The base thing for developing such application is a class and object, right? And when you design any software using object orientation, then that object orientation will basically deal with the internal design of the software, not the external design, right? Then you need to understand what is internal design and what is external design, right? So internal design means it is basically used by the programmer. And whenever I'm saying external design means with which the end user can interact. Suppose, suppose you are developing one application. So while you are developing the application, these things, right? Whatever code you have written, this is your internal design, right? And here working writing the code is the responsibility of a programmer. Programmer is going to write the code. That means it is the internal thing of the application, right? But when you run the application, the end users, yes, suppose you develop one application and you give that application to some company or some organization, or you host the application on web so that anyone can access, then the user who is going to interact with the application, they are going to interact with the external part of your application, right? So see here, you can see 30. So this is shown by to the user. Now the user can interact with this console, right? So this is external. This is the external part of your application. Whatever code you have written, this is your internal part of the application. So internal part, programmer is going to interact. External part, end user can going to interact. So as object orientation means it is basically deal with the internal part. So the programmer is going to interact with the application through object orientation. Is that clear? Yes or no?
Yes.
Then, third point. So with the help of object orientation, the application developments or the programming becomes more and more systematic, and we can follow the procedural of engineering to develop software, right? Like in other engineering, how a product is developed, in the same way, a software product is developed by adopting object orientation. See, whenever you join any BTech institution, they are not only giving you computer science education, right? They are giving you different type of engineering, right? There might be have electrical engineer, there might be have automobile engineer, mechanical engineer, civil engineer, right? So there are different kind of engineer, right? And how the other engineers developed a product, the same way we software engineer also develop our product. Then first of all, we need to understand little bit how other engineers develop their product, and then we will compare our software engineering with other engineering and try to understand what is the similarities between them, right? If you take a little bit about other engineering, like a civil engineer. So a civil engineer is constructing a building. Then first of all, he or she will make a plan or will make a design. See, suppose one building a civil engineer wants to develop. He cannot start developing the building from the day one. First of all, he need to design a plan. He need to design a architecture of the building. So plan of the building. So basically, he will make a design, and that design he will make on the pen and paper, right? And once he finalized the design, once the design is finalized, so that design may be finalized on pen and paper, right? Once the architecture, once the plan, or once the design is fixed, then only the engineer will start constructing the building. Yes or no? So they are not going to develop the day one. First of all, they will make the blueprint of the design, or you can say a plan of the design. So you can say they will first make the design. Once the design is finalized on pen and paper, they can start the actual constructing of the building, right? Nowadays, nobody is using pen and paper. They are using some computer tools, right? By using those computer tools, they can prepare the design. But consider that the construction of the design is based on the pen and paper, right? So once the design is finalized, then only the actual construction start, right? So in the same way, if you take an electronic engineer, right, when he is manufacturing any device, he will come up with some design. That design may be the circuit design of that device and on the paper. So once he finalizes the design on the paper, then only he can start manufacturing the device, right? So the point that you need to understand is any kind of engineering you take, they are not developing or they are not constructing from day one directly. First of all, they have to make a blueprint. First of all, they have to make a plan. First of all, they have to make a design. Once the design is finalized, then they only start manufacturing the actual product or actual building or whatever you may say. For example, if any automobile company, right, if they want to design a car, first of all, they have to, if they have to manufacture a car, so the car is not manufacturing directly, right? First of all, for that for that car, they have a blueprint, they have a design, and based on the design, they can manufacture any number of cars, right? Right. So you can consider BMW. BMW design is there. Based on the BMW design, they can manufacture any number of BMW cars. Yes or no? Hello?
Yes, sir. Yes, sir.
Right? So the point that you need to remember is that, so the point that you need to keep focus is that on paper, we make blueprints or a designer plans. Nowadays, we are not using paper. We may have a computer editing tools. We can use those tools to make our design. But let's just imagine on paper, we are working on and we are preparing our design or blueprint or plan on the paper. Right? That's what we just understand now. In the same way, for developing a software, we have to do some paperwork. We have to come up with a blueprint or a design or plan, and then we start developing the application, right? So in our programming, in our computer world, or in our software industry, we are also following the same principle, right? We are not going to start the developing from day one. If anybody are working in a real-time industry, then they might know there is happening some Scrum, right? They are having there might be some documentation before start developing any functional. So first of all, we need to discuss what is the role, what is the module, what are the things we need to what are the things we need to develop. A high-level architecture is there, high-level documentation is there, right? Without documentation, we are not going to start any developing because we don't know what is the requirement, what are the things we are going to implement as part of this function. So first of all, we have Scrum is there, we have meeting is there, right? There are a different teams. So one of the team get the requirement from the client, and that team will discuss with our team leader. So what is this is our requirement, right? Then the team leader will get the document from the BA team, business analyst team is there. They will prepare the document, right? They will provide the document to you. That document is not in your coding document. That is a high-level document. This is our requirement, and this is the functionality. When user click on this button, this thing should be happen. All these things they will make a document, right? Based on that document, then you will start thinking, then you will start analyzing, and then you will start developing. You are not developing from day one. First of all, you should have a proper documentation. You should have a proper blueprint, right? Without documentation, if you are developing, that means you are not doing the actual software engineering, right? So documentation is important, but I can see in many small industry they do not have a proper documentation, right? But if you are going to work in a big MNCs, then you will see that documentation play an important role. Whatever functionality you are going to achieve, you should have proper documentation, right? So documentation is nothing but your blueprint you can consider, right? Once you have finalized the blueprint, then not only a single portion, a team of programmer can work on a single project, right? And once a team of people can work on a single project, that means the work can be distributed easily among different developers, and the work can be shared between different developers. Yes or no? Suppose I started developing one module, and then if I'm having some other work, if I'm not available or I'm not coming to office, then that the task can be shifted to someone else from my team, right? Because I'm not the one I'm going to work on a single project. Project means a team of people are going to work, and even a team of people are going to work. In one team, we are developing. In another team, there are some data, there are some testing people is there. Another team, database team is there. Database team taking part of the database activities. As a developer, we are taking the responsibility of the coding part. Testing team, they are going to prepare some test cases, right, based on the requirement given by the BA, so that when you complete your developing, you will provide that a functionality to the testing team, so that the testing team can test and can give the sign up that whether the functionality you have implemented is working fine or not. See, and the testing team is not the individual, right? There are, whenever I'm saying a team, means it is more than one people. It might be possible that in some rare cases only one people is going to work in a single project, But in that case, the project size is very less, right? If you have very small project, then it might be possible that one person is going to work. But for bigger project, definitely a team is going to work. Is that clear?
Yes.
Okay. Now let's come to the next one. Object orientation all depends on how you see the system and how you understand the system. Looking at the system and your perspective is more important. So if you understand the system perfectly and if your perspective is clear, then you can develop a better system. See, whenever some requirement is come to you, first of all, you need to identify, you need to understand the system. When I'm saying system means the functionality of the application, right? Without understanding the functionality from A to Z, from the starting to ending, you cannot develop a better software. Because if you want to develop an application, then you need to think in terms of that, what is going to happen in the future, right? What is the interrelated functionality? Suppose I am developing one function, it should not affect the other functionality, right? So if I'm developing one function, but it will down or it will make some problem to other function, then it is not your aim. So you have to think the system, right? How you understand the system, that basically decide how you better design your application. Understanding the application, understanding the system, understanding the requirement is the most important thing. Developing is not that important. But see, I see many people are coming and many people are joining the company and they start developing without understanding the system, right? So what generally they does is, so suppose some small tax is given to them, they just work on that particular small stack without understanding the system, right? This is should not be the case, right? See, whenever you are going to start developing, first of all, KT session is there or not? Yes or no?
Yes.
Yeah. So what is the meaning of KT? KT means they will make you understand the system. In the KT session, they are not going to tell you this is a my line number 2, line number 3, line number 4, right? They are not going to explain in the code. What they will explain you? The functionality of the application. They will make you understand the system properly, right? Once you understand the system properly, then understanding the code is not a big deal, right? But if you don't understand the system, right? If you don't understand the UI part of the system, right? This is my UI. Whenever I click on this thing are happening, right? Behind the scene. This is my database, right? This database having many number of tables. What is the relation between each and all of this table? If you don't understand, then you are not going to develop a better software. If you understand the system perfectly, then if some issue comes, right? If some issue come, then you directly say, yeah, this is the issue and this issue because of this reason, you can clearly identify because you have a good understanding of the system, right? So that is, so the best part of object orientation is how you see the system, right? How you understand the system. Understanding the system is very important. Now, object-oriented programming, there are other programming styles are also available like procedural, modular, or structure. But object-oriented programming is a well-known and successful one for software development. And most of the latest languages that are used for application development, they use object-oriented. This is what we just discussed. Now what we are going to do, we are going to compare object-oriented with our procedural or modular programming and try to observe at what scenario you need to go for modular programming and what scenario you need to go with object-oriented programming, right? So this, why I'm going to explain this is because, see, you might not have any experience on Java programming language. You might not have any experience in C++ programming language, but you should know about C programming language because in academic, in every institution, in every university, C language is mandatory, right? So C, you can say C is the base of all programming languages, right? Even people are saying C is the mother of all programming languages. If you understand the C programming language very clearly, then you can understand all other programming languages very clearly, right? So if you look at my the basic part, what we have completed yesterday, most of the things are available in C programming languages or not? So call by value, call by reference, pointer, we have a variable, operator, functions, everything is available in C programming languages or not?
Yes, they are.
Yes. See, that's why it is also said, people are also saying that C is the mother of all programming languages. How good you understand the C? So that will decide how easily you can understand the other programming languages, right? Yeah. So some of the syntactically difference is there, but conceptually concept is going to be same. Function means the meaning is same. It is same in C programming languages. It is same in C++, and it is same in Java and C#, right? What is difference? How you are creating the function and how you are calling the function. That is the difference, and that you learn in each programming languages, right? So let us compare our C programming languages with C Sharp, so that C is going to be your modular or procedural programming language, and the C Sharp is your object-oriented programming languages, right? So let us compare object-oriented programming with some examples. So let's take the example of a bank, right? Suppose you are developing an application for a bank using modular programming or structural programming. Then first of all, how do you see the system? How you do see the banking system? How you do see the working of a bank, right? And what will be your design, right? See, if you want to design, first of all, you need to understand the system. First of all, you need to see the system. First of all, you need to understand how the banking system works, right? Once you understand these things, then you will design your application. You will design or you will make a blueprint of your application, right? So that basically depends on how you understand it and how you see the system, how you understand the banking system, how you understand the bank. That basically depends, right? How you could and how you are going to design the application, right? So understanding the system is the most important thing. Once you understand the system, then only you can do a design of your application. See, if you don't know what are the functions or provided by the bank, then how you can decide and how you can design your application? Yes or no? Suppose in bank, you can see there are many functions available in the bank. If you know in bank, you can open account, you can deposit account money, you can withdraw money, you can check balance, you can apply for a loan. So these are nothing but one function provided by bank. And if you don't know what is open account, and if you know there is some functionality called deposit, there is some functionality called withdraw. If you don't know this thing, then how you can design the bank application? So if you want to design the bank application, then first of all, you need to understand these functionalities, right? So there is something called open account. A user can open an account. A user can deposit money. A user can withdraw money. When deposit means it's going to be added to his existing amount. Withdraw means it will deduct from his existing amount. There is something called a bank transfer. You can transfer the money from one account to another account, right? You can check your balance. You can apply loan. You can get, right? These are nothing but your functionality, right? In a bank, you can open an account, you can deposit account amount, you can withdraw amount, you can check balance, right? You can apply for a loan and so on. So these things are the things that you do at a bank. Yes or no? Hello, guys.
Yes, sir.
Right. So in modular programming approach, so you understand the system. This is nothing but your system. So once you understand the system, then you need to make a design or not. So in modular programming approach, right, how you will design. So for modular programming approach, you will create one open account function to achieve this functionality. You will have another function for deposit. You will have another function for withdraw. Similarly, function for check balance. You have one function for apply loan. So in modular programming approach, each thing is going to be implemented as a function, right? So these things are nothing but one function, and you can do specific operation by calling that function, right? Suppose you want to deposit money, then you need to call this deposit function. Suppose you want to withdraw money, you need to call this withdraw function, right? So this banking system with modular programming approach is nothing but, you can say, it's a collection of functions. Yes or no?
Yes.
Yes, sir.
Right. So that means this bank application using modular programming approach is developed as a collection of a function. And if you want to perform a specific task, then you need to call that specific function, and that specific function will do the required tasks, right? So you will develop in terms of set of functions in modular programming. Is that clear? See, if you are taking the example of C language, so C language, so everything you defined as a function or not? Is there any class object concept? No, there is no class, no object, nothing is there. You have to define functions, and from your main function, you will call one function. From one function, you will call another function. That means C programming language or modular programming language, it's nothing but it's a collection of functions, right? So this is how you understand the system, and this is how you develop the modular programming, right? So modular programming means collection of functions. So if you want to develop any application using modular programming, means you have to develop a set of functions. That's it, right? Now let us understand what is object orientation. And for object orientation, we will take a different example. Suppose we are going to develop a project for any government, right? And you know, in government, government provide different kind of services like electric service, water supply service, education service, banking system, transport service, right? Like this, they are providing many services or not? Yes or no?
Yes.
Okay. And these services are nothing but one department of a government or not?
Yeah, individual departments.
Yes. Then as a user, what this department, then what you can do in this department as a user? Suppose you are a user, right? Then what you can do inside this electric department? You can apply for a new connection. Yes or no? You will apply for a new electric connection. If you are having more connection, then you can, I mean, you can close one of your existing connection. You can pay the bill, right? So these are what are the things you can perform on a electric department, right? Similarly, you can do the same thing in a water department. Now, in the same way, bank is also there. The same functions like open account, deposit, withdraw, check balance, apply loan. So all these things you can do inside the bank department or not?
Yes. Yes.
So in each department, you can do a number of functions. A number of functionality is provided in each department. Electric department functionalities belongs to electric department. Banking functionalities like open account, right, deposit, withdraw, all these functions are belongs to bank department. Similarly, education, there are a different education system, right? Transport system is there. So each system or each department having a lot of functionality, and that you can do as a user, right? So we call this as objects, right? So what we do call this, we call them as objects. So the complete system for the government or software of the government is a collection of objects. So this is one electric object, water object, right? So in electric, education, bank, we call them as one object, right? So in terms of object-oriented programming, we are saying it is one object. We are saying it is another object. We are saying it is another object. This is another object. This is another object, right? In terms of object-oriented programming, we are not treating them as function. We are not saying electric function. We are not saying water function. We are saying electric object. Inside this all electric object, we have many functions. Inside this bank object, we have many functions. But previously, if you compare this, we are not saying object. We are saying these are one functions. There is no concept called object. Everything is defined as a function. Here, everything is not defined as a function. Everything is defined as an object, electric object, water object, education object, bank object, transport object, and inside each of these object, we have different kind of function. If you take the example of a bank object, then inside bank, you have open account function, you have withdraw money function, you have net banking functionality. So these are implemented as one function inside the bank object. If we take the example of an electric object, Then inside the electric object, we have a different kind of functionalities. You can create a new connection, you can close an existing connection, you can do your bill payments. So these are nothing but one function defined inside the electric object, right? So we can say this project, this government project is nothing but, can we say it's a collection of objects?
Yes.
Yes.
Yes or no? Yes. Now, can we, and each object is having its relevant function or related function. Electric department or electric object having some function which are specific to electric object only. Bank system or bank object having some related functions. These are specific to bank object, right? So if you want to perform some banking functionality, first of all, you need to create the bank object. And once you create the bank object, then you can call the functions which are specific to the bank object. You cannot call the electric department function using the bank object, right? If you want to call electric department function, you need electric object only, right? That means each object having its related functions only. So a complete software is a collection of an object and object containing function as well as data related to those functions. Is that clear?
Yes.
Okay. So this is, so in object-oriented programming, we treated everything as object and object containing function. But in modular programming, the system was a collection of functions. Yes or no? So if you compare them in modular programming, we are looking at a very close level, and in object-oriented programming, we are looking little far away level, right? So say in modular programming, everything we are seeing as a function, right? But in object-oriented programming, function is there, but we are seeing far little away. Away means in the sense we are just seeing the high-level design. High-level design in the sense object having those functions, but we are seeing the object. That means you are seeing very high level in terms of object-oriented programming. This is what we are mentioning. In modular programming, we are looking at very close level. Close level means we are looking at directly at the functions, and in object-oriented programming, we are looking at a very little far away level. Little far away level means we are looking in terms of object, but object having the functions only. Is that clear?
Yes.
Okay.
Yes.
Now, if you look things closer, like if you go to the bank, then everything inside that is nothing but a set of functions, right? When initially computer science was introduced, computers were used for performing some simple or very small tasks, right? So when initially the computer was introduced, at that time we are not doing very big or complex calculation using computer. Very small tasks are going to be performed on the computer, right? Then later on, people started using computer for larger and bigger tasks, right? Initially computer was not meant for bigger tasks, but once people acquainted with computer, they started using computer for larger and bigger tasks, right? So when the C language was introduced, or when the procedural language was introduced, everything was not computerized, right? Everything was not computerized means what? Now for any organization at that time, everything was not computerized. Rather, they computerized some of part of it. Like suppose one organization, there are many different departments, but they have computerized only one department, right? Like the account part of a system or payroll part of a business. So one system is there, only account part, they have designed some software to manage the account part, or they have designed some software to manage the payroll part of the business, right? So what it means, everything is not computerized, only part of a business is computerized, right? So when the programmers were working on any particular department, they were looking at everything as function, right? So as we discussed, C is a procedural or modular programming languages, and in modular programming languages, we see everything as a function. Yes or no? This is modular programming. We see everything as a function. In object-oriented programming, we see as object, but in modular programming, we see as function. This is what mentioning here, right? So when the programmers were working on any particular department using C language or procedural language, they were looking at everything as functions. But now we are developing software at a larger scale for a big organization. as a complete one single software, and then you can see all the things like set of objects, right? So if you are developing as part of a business, and initially when C language was there, they are just used for small operations, right? One business organization is that some of the part of the organization or some part of the business they have designed using some computer, right? They have managed using computer, not the whole. But nowadays everything is automatic, right? Everything is managed by banking system. See, before 15-20 years, do you think that everything in a bank, everything is computerized? No. But nowadays everything is computerized or not, right? Before 20 years or 15 years, if you want to withdraw money, then you have to go to the bank, you have to stand in the queue, you have to fill up the form, then you have to deposit the form to the bank account manager, right? Or to the cashier. He will verify, he will do all these things manually or not, then he will give you the money. But nowadays I can say this thing is applicable, but nowadays 95% people are going to the ATM only, right? That ATM is doing the online transaction, withdraw money, transferring the money. Yes or no? So that how it is possible, because that is possible because of the computer system, right? We are completely managing the banking system using software only, right? If you take any big larger organization, everything is managed by software nowadays, right? And in terms of software, and if you want to develop any application in terms of object orientation, then you need to treat each thing as an object. But the same thing, if you want to develop using modular programming language, then you need to treat everything as a function, right? If you are developing any application using modular programming, you need to treat them as function or a collection of functions. But if you want to develop application using object orientation, then you need to treat them as objects, right? So back to the example, electric related things are function related to the electric department, transfer related functions are related to the transfer department. So we have increased our level of looking at the system, because we are solving small problems, but now we are solving bigger problems. Then there was a need for some methodology that should support software development easily. So yes, object orientation is best suitable for large system, right? Is that clear?
Yes.
Now, why object orientation? Let us talk about a manufacturing firm which manufacture cars or vehicles, right? If you look at the manufacturing firm, then it may be working in the form of a department, like one is inventory department that maintains the stock and raw materials, one is manufacturing department, that is the production work they do, and one department will be looking at sales, one department is looking at marketing, and one department is about managing the payroll system, and one is for accounts and so. That means if you are going for a manufacturing firm, it means there are lots of departments, there are many departments. Now if you are developing a software only for payroll purpose or only for inventory purpose, then you may look at the system just like a modular approach, right? So this manufacturing firm having, let's say, 10 departments. But if you just want to develop a software for the payroll department only, then you can see the system like a modular approach, and you can develop the function. I mean, you can develop the payroll software by using a set of functions. Like this type of things, you can have a set of function in that. So you can develop the software for the inventory system as a collection of a function. But when you are developing a software for the entire organization, right? I'm not going to develop a software for the payroll department only or for the account department only. Rather, if I want to develop a software for all the department, if I want to manage the entire manufacturing firm functionality, then I should not go for modular approach. What approach I need to go for? I need to go for object orientation approach, right? So the inventory is an object, right? In this case, if you are going for inventory approach, if you are going for the object orientation approach, then what you will see? Then how you will see the system? You will see the system as like this. Inventory item is an object. Employee is an object. Account is an object. Product manufacturer is an object. Machines that are used for production are object. That means everything what you see in the manufacturing part is nothing but an object. So all these things are object. Here you need to see the things in the form of an object and define their data and functions. And define the data and function means, so for each object you need to define what are the data we require for that object and what are the functions we need to define for that object which process the data, right? So from a higher level we need to see in terms of object orientation, right? But for if you want to develop a small task, right, if you just want to develop a part of a single a part of a full organization, then you can go for modular approach. But if you want to define all the functionality of a firm, right, if you want to develop a software to automate all the business of the firm, then you need to go for object orientation, right? Whenever you go for object orientation, then you need to see all the things what are available inside the firm in terms of object in an organization, right? So everything, so employee, car, boss, right? I mean, whatever the requirement, whatever the things available inside a bar, and whatever the things you are going to use in your project, you need to see them as object. And as part of object, you will define some data and you will define some functions, right? So that we'll discuss how to define data and how to define functions. We'll see these things practically, but for now, you need to see in terms of an object only, right? Is that clear?
Yes.
Right?
Yes.
Yes, sir.
Okay. Now if you are moving, see, if a small application you can develop using modular approach, and for a bigger application you need to go for object orientation approach. Then you should understand, if I am developing the application using modular approach, then what are the problems, right? And how we can overcome those problems using object orientation approach, that we need to understand. So basically modular programming have 4 problems, right? What are the problems? The problems are reusability, extensibility, simplicity, and maintainability. Reusability, extensibility, simplicity, and maintainability. Now, what is reusability? In modular programming approach, we need to write the same code or logic at multiple places, which increases the code duplication, right? There is no concept of a code reuse. We do not have the concept of a class and object, so that we can create the object and we can invoke the method, right? There is no such functionality. If some code is required at many places, you have to write the same code, right? That means there is a chance of code duplication. So if code duplication is there, means we are not using the code again and again. That means code reusability functionality is not there, right? Understand or not? Reusability means if you reuse the logic, but if you are not reusing the logic, rather than you are rewriting the logic again and again, means what? Means your code having duplication. You are writing duplicate code in your application. And in modular approach, we are writing duplicate code. Second problem is extensibility. It is not possible in modular programming to extend the feature of a function. Suppose you have a function and you want to extend it with some additional features, then it is not possible, right? So in our previous session, we have discussed that a toString method, that equals method are defined in an object class, right? They are having some functionality in the object class. But if you want to if you want to extend the functionality of those methods, then you can override those methods in your class or not. That means you are extending the functionality of a function. But this is not possible using modular programming approach. You cannot extend the feature of a function. Then what you need to do? You need to rewrite a completely new function. You cannot extend the functionality. If you want to extend, then you have to create a new function altogether, right? So this is the problem of extensibility, right? And simplicity means, as you do not have reusability and as you do not have extensibility, we end up with lots of a function and lots of a scattered code. Lots of a scattered code means a duplicate code, and we have written lots of function, right? So in this case, say if you can see that equals method is defined in the object class, and I can define the same equals method in my employee class or any class, wherever you want, you can override. That means the equals method is going to be same. But if you want to do the same thing, means you cannot do the same equals method, right? You have to create a new method altogether. You have to create equals 1, equals 2 like this, right? That means lots of function you are going to create it, and even this reusability functionality is not there. That means you are going to write the duplicate code at many places, right? So that duplicate code is nothing but your scattered code, and you are creating or you are ending up with lots of functions, right? And maintainability means, see, if you are having, if your code is duplicated, if you do not have the extensibility functionality, if you do not have the simplicity, then do you think that managing your application code will be easier? Do you think that? No, it will be very difficult to manage the application code. Why? Because you have written one functionality at 10 places. Tomorrow you want to change the functionality, right? Then what you will do? You need to do the same thing at 10 places or not. If you by mistake missed a few places, then your application is not going to perform as per your expectations, right? So maintaining the application code will become a headache for the developer, right? So these are the problems that we generally face using modular programming approach. Is that clear?
Yes, sir.
Okay. Now we will discuss how we can overcome such problems using object orientation approach, right? So you can see object oriented programming is a design approach where we think in terms of a real world objects rather than functions and methods. We are not going to think what are the functions and what are the methods available. What we will think? We will think in terms of object only, right? See, we have 4 problems. Basically, we have these 4 problems, and how we address those 4 problems using object orientation. Let's see. So we have something called reusability. Class and object is there, right? Once you define some, once you create one class, and inside that class, once you create one class, then you can create any number of object of that class. Yes or no? We have already discussed. We can create n number of objects, right? That means we can reuse the code. Right? In one place, I can create the object and I can invoke the method. In another location, I can also create the object and I can invoke the function or not. That reusability functionality we achieve in our object orientation through class and object. Is that clear?
Yes.
Yes.
And then we have something called simplicity. See, we have some concept called abstraction. We have some concept called encapsulation. We have some concept called polymorphism. So using this concept, we can achieve simplicity, right? We can see, once we declare a class, if that class having 10 number of methods, and if we want, we can only expose 3 methods to the user. 7 method we can hide, so that user of our class do not be confused regarding why number of methods. Only what is required that we can expose, right? Even if we are having some data member, and if you don't want to expose the data member, right, then we can make them as private. So once you make them as private, those things will not be available. Polymorphism means several implementation, right? If you want one function to be behave differently when the input changes, then you can achieve the same. And if you want one class performing some functionality and I want the same method to perform differently in a different child classes, then you can also do the same using the concept called method overriding, right? So this we can achieve the simplicity things we can achieve in CSharp, or we can achieve in object orientation by using this concept: abstraction, encapsulation, and polymorphism. Right. Extensibility. So extensibility means you have defined some functionality in a parent class, and you can, if you want to reuse in the child class, then you can reuse it. If you want to extend the functionality, or if you want to extend the behavior, see, in our example we have already seen. So equals or toString method is defined in the object class. Even they are defined in the object class, they are performing some default operation. They are right. And if you want to modify, if you want to extend the functionality, then you can also extend that functionality in your class by using or by overriding the methods. And that is possible only because of inheritance. Inheritance concept is there. So it is possible to extend the functionality. We are something called aggregation. We are something called composition. See, aggregation composition in the sense what? Now suppose you are having a car and one class is car and another class is employee. So you can make the relationship like EJ relationship, or you can also make the relationship as a Haja relationship, right? It is also possible that you can make employee is a car. You can also make employee has a car, which makes sense. It makes sense to make the relationship as a Haja relationship. Employee has a car, it makes sense. But employee is a car, it doesn't make any sense. So aggregation and composition is there, which you can implement or which you can achieve, which you can use for extending the functionality of your application. And because of this, once you combine all these things together, extensibility, reusability, and simplicity, you can manage your application in a better way. Your code is clean, right? There is no duplication code, right? There is no scattered code. So you can manage your application code in a better way. You have clean code, you have managed code. So you can manage the code in a better way. Some changes comes tomorrow. You can change them very easily. You want to extend the functionality of a function, you can extend it very easily, right? So because of this thing, maintaining the application code becomes very easier. Is that clear?
Yes, sir.
Okay. Now we are going to discuss what are the OOPS principles, right? See, what are the OOPS principles? So OOPS basically provides us 4 principles. What are those? Encapsulation, inheritance, polymorphism, and abstraction. Some people are saying data hiding. Data hiding is nothing but by using the encapsulation principle, we can achieve data hiding. But data hiding is not a principle. So we have only 4 principles: abstraction, encapsulation, inheritance, and polymorphism. And guys, many people are getting confused regarding class and object. See, class and object are not OOPS principle. Never treat class and object as one OOPS principle. Don't consider class and object as OOPS principle. Then what class and object are? Now, class and object are basically used to implement OOPS principle. Is that clear?
Yes.
Yes or no?
Yes.
So OOPS means only 4 principles. What are these? Encapsulation, abstraction, inheritance, and polymorphism. And if you want to implement or if you want to achieve this principle in your programming language without a class and object, you cannot achieve it. Right? Class and object are basically the base you can consider to implement OOPS principle in any of the programming languages. You can take Java. There is the concept of a class and object. You can take C++. There is the concept of class and object. You can take CSharp. There is a concept called class and object. So class and object are not OOPS principle. OOPS provide only these 4 principles. And don't consider data hiding is a principle. Data hiding is a concept which we can achieve through encapsulation principle, right? As we are comparing software development or software engineering with other engineering, we want software development should also be done just like other engineering. So how other engineering develop their product, how automobile engineer develop a car, right? So in the same way, we want to develop a software also. So the object orientation supports a programmer to develop any application just like how other engineering develop their product. Like electronic engineer is making some device, and automobile engineer is making some vehicle. So the software engineer also wants to follow their approach. So that approach gives these 4 principles. So that approach, see, whatever the approach we are following in other engineering, if you want to follow those approach and to develop a product in software engineering, then you need to follow these 4 principles. Is that clear?
Yes.
Okay. Now, when we come to software development, that is programming, what are the main elements of programming? There are the 2 main elements of programming, that is data and operation on the data, that are functions, right? So data and function are the 2 important parameters or 2 important things when in terms of object orientation programming, right? So you can see, so this is a class, right? So you can see this is a class. So what we can define inside the class? So this is nothing but I'm declaring some variable, right? So this is nothing but your data. This is nothing but your function. So when you are comparing object orientation programming, then there is nothing but only data and the function. You cannot find anything else. Data, and using the data, we have some operations, or you can say some functions which operate on the data. So we have only data and the function, nothing else, right? So the function perform operations on the data. So whatever variable you declare, those are going to hold the data, right? Suppose you are making one database call, right? Then database call means you are doing some operation on the database, and for performing, after performing some operation, means what? Means you are doing some operations on the data, right? The data in the sense, database is basically used for what purpose? To store the data, right? If data is not there, then what is the meaning of a database? There is no meaning. And if data is not there, then what you will do with this function? You cannot do anything, right? So data is the most important thing, then function, right? If data is not there, there is no meaning of function. But if there is no function, then there is meaning of data, because without function, you can only create the database. Now, in the database, you can store the data, and you can manually operate the data. In SQL, you can write some function, right? In SQL, you can write some select statement, you can write insert, update, delete statement, you can perform different kind of operations on the database directly. But as a user, right, nobody is going to interact with the database directly. So we need to give an interface. And for that interface, we are developing the software, right? The user will interact with the user interface, and behind the user interface, we are going to write some code, and those code is going to operate on the data which is stored on the database. Is that clear?
Yes.
Yeah, so operations on the data. Data is the most important thing. There may be many functions, and there may be a huge collection of data. So when you develop software, the software is performing operations on the data only. So the programs are based on the data. Data is primary, then the operation on the data are set of functions, right? So data is the primary thing, then the operations on the data you can perform, right? So if data is not there, then nothing is there. If you lost the data, you lost everything, right? If you have data and if you lost the function, then you can create the function, right? So, right, suppose you are writing one, developing one application, that application is crashed or that application code is deleted, then you can create the application again. Na? But if you are storing the data in the database, and if the database is deleted, then from where you will restore the data? You cannot. Na? You can write the logic, but you cannot write the data, right? Data is the primary thing. So data should be take the more priority than functions, because we can create our functions, we can delete the function, we can create the function, right? We can remove the function, but data you cannot do things, right? If you delete the data, means data is lost. But if you delete the function, then data is not lost. We can recreate the function, and we can operate on the data. So that is what you need to understand. If you take an example of automobile car, which have metal, wire, cable, or plastic, these are the things that are used for making a vehicle. And these things are nothing but your data. If we talk about electronics, then electronic circuit, PCB boards are used for making an electronic device, and these are nothing but your data. Same way, what is used for making software? We need data and functions on the data. Is that clear? Right? So if you are developing one application, means you need data and you need function which will operate on the data, right? See, a database software where you can store the data, but the end user cannot directly interact with the data. Na? So for that end user to interact with the data, you need to give an user interface, right? So that user interface is nothing but you are going to use a programming language for developing, right? And that user interface having set of functions which is going to operate on the data. And to hold the data, you need some variables in your application, right? Those application is going to hold the data, and you need to create some functions which is going to operate on the data. But at the end, if you want to fetch the data, you have to fetch from the database. And if you want to update, modify, delete the data on the database, then you have to make a call to the database, right? So data is the most important thing, and then function comes, and data and function together makes a software, and that software can be used by anyone, right? Is that clear? Hello,
Yes.
right.
Yes, sir.
Okay. Now we are going to discuss the four principle, right? So four principle in the sense I'm just going to give the definitions, and in their respective chapter we'll discuss all these concepts in detail. So we have separate chapter for abstraction, encapsulation, polymorphism, inheritance, right? All these are special one chapter, and in that chapter we are going to discuss the things in detail. But for now, I'm just going to give you a definition. So this is the book definition. The process of representing the essential features without including the background details is called abstraction. So if you look at any book in your academic, then you might know this definition. The process of representing the essential features without including the background details is called abstraction. If we simplify this definition, then we can say that it is a process of defining a class by providing necessary details which are required by hiding or removing the unnecessary things. Right? We'll understand this with an example. Right? Let us understand the other definition for encapsulation. The process of binding the data and the function together into a single unit is called encapsulation. In other words, we can say that it is a process of defining a class by hiding its internal data members from outside the class and accessing those internal data members only through publicly exposed methods or properties. It's called encapsulation. Data encapsulation is also called as data hiding because by using this principle, we can hide the internal data from outside. Abstraction and encapsulation are related to each other. We can say that abstraction is logical thinking, whereas encapsulation is its physical implementation, right? See, this is one class, right? And in this class, I'm declaring some variables, right? Private integer x equals to 1. Then public integer y equals to 10. Now, if I create the calculator object, right, then if I click on this, then you can see only y is there, x is not there, right? Why? Because we marked x as private. So when you marked x as private, then it is not accessible to outside the class. What is public? Those things you can only access. You can access this calculate sum method and you can access this one. These are public. So what it means, the process of representing the essential features without including the background details is called. So what it means now, what is required, we just provide access to the user. What is not required, you just remove. So in this case, you can see we have removed this one. So the user of our calculator class can never access to this. He can only access to this private member. So whatever private member, you cannot access from outside the class. Whatever exposed means whatever public, those are exposed, and those you can access from outside the class. If you take the example, let us understand abstraction and encapsulation with an example. Suppose you want to design one class for providing the registered functionality of you. Suppose you want to create one class for registered functionality. You can say a Gmail account. While you are creating a Gmail account or Facebook account, first of all, you need to sign up or not. Sign up means you are registering yourself inside the application. And if you want to provide the registered functionality for the same, then what you need to do? First, you need to get the data, and first you need to get the data. Suppose you have provided some text boxes, radio button, drop-down list, and by filling those, and whenever you click on the same button, that means you will get the data. Your application get the data. Once you get the data, then what you need to do? You need to validate the data. Once you validate the data, and if everything is working, if everything is fine, then you need to get the connection string for the database. Once you get the connection string in the database, then you need to save the data in the database, right? So, and for this, what you have done, you have created three methods. First of all, the user has to call the validate method, then the user have to call the get connection string method, and then the user have to call the save user method, right? In this case, first you will call this method will validate the data, then he will call this method will get the connection string, and then on the same connection string, you need to call the save user method, which will save the data in the database. But if you provide access to these three methods to the user of this class, then he may end up calling these methods in the wrong order. It may be possible that he may forget to call any of these methods. Yes or no? Suppose the user
not calling this validate method, simply call this get connection string and save user method. That means this validation is skipped. What it means? It means we are if there is some validation issue, then this issue is not going to check. That means we are going to store the wrong data in the database, right? Suppose the user call this validate method, but he forget to call this get connection string method. He directly call the save user method. Then what will happen? There is no database connection string. Then it will give you some exception, right? Or it might be possible that the user only call this method and this method he forget to call this method. Then what will happen? The thing is that this method is called data is validated, but this method is not called. That means the data is not saved in the database. That means if we are providing access to these three methods, then we may end up some issue, right? We may enter wrong data, and it might be possible that data is not saved in the database. It might be possible that we may save wrong data in the database. It might be possible that we may get some kind of a exception. So here, what you need to do is, you need to create one method called register, and as part of that method, you need to call these three methods in turn, right? And finally, you need to give access to this registered method instead of these three methods. This is what we discussed. It's nothing but abstraction. Abstraction means only provide the necessary details, right? So here, providing the necessary details means we are only providing, or we are only exposing the registered method. We are hiding the internal implementation data. How this method is internally calling this three method and how these three methods are implemented, that is hidden to the user. That means this is nothing but abstraction. And how we can achieve this? That is encapsulation. How you can achieve this means you need to declare this method as private. You need to declare this method as public, right? Once you declare this method as private, then they are not exposing. And once you declare this method as public, then it is exposed to the user, right? So you can think. So here you need to create this three method with the private access modifier, and you need to create this method with the public access modifier. So you can see. So suppose this is your registration class. The user now not calling this private three methods. The user now calling this registered method. And these three methods are not even shown to the user because you make them as private. And but these three private methods are internally called by this registered method. Is that clear? Okay, let me explain you this. Suppose you are creating one registered method, right? Let me create three methods: public, validate. So this is one method, public void validate, right? Then get connection string, right? Then save user, right? Now what will happen now? Now, if you create an instance of this is your class and this is the user class. This is from here we are going to use the registered class. So now, if you see registered dot, then you will see all these three methods are not get connection string, save user, validate. Suppose I'm calling the validate method, and then I'm not calling the get connection string. I can directly call the save user method. Is that possible or not? Is this possible or not?
Yes.
Yes, it is possible.
It's possible. For example, let's say you have forgot to call this validate method, right? So you just call this registered method and you just call this get connection string. Is this possible or not? It's possible. So in this case, you are entering wrong data into the database. Yes or no? Because you are not validating the things. And again, right? Again, in this case, for example, you just call these two methods, but you forgot to call this method. Then in this case, what will happen? In this case, you are validating the data, but you are not saving the data into the database, right? So this is, you should not develop the application like this. Then how to develop the application? You need to develop the application like this, public. You can say void register or is here registered user, right? And inside this method, you just call the validate method, you call the get connection string method, and you call the save user method. And what you need to do, you need to make this as private, you need to make this as private, and you need to make this as private. Once you make this as a private, you can see you are getting some error here, because now what is necessary to expose only this registered method, what is not required, these three things are not required. So we are hiding the implementation. How this method is implemented, that is hidden to the user of this class. So who is the user of this registered class? Program class. Program class doesn't know what is this validate, what is this get connection string, what is this save user method. What program class know is, you know only the registered method. So what you will do, you will just call the registered user method, right? So this is what we discussed. It's nothing but encapsulation and abstraction. Thinking is nothing but your abstraction, right? You need to think. I need to declare three methods as a private method. I need to declare one method as public. I need to provide this public method to the user so that the user can call this method. And I need to define three methods inside this method. I need to call all this method inside this method, right? So how you are implementing is encapsulation. How you are designing is nothing but your abstraction, right? Is that clear?
Yes.
Yes. Okay. Then the next concept or next principle is inheritance. The process by which the member of one class are transferred to another class is called inheritance. Inheritance means what? Now we need to make a parent-child relationship. Whenever the term inheritance comes, means there are at least two classes, right? One class will be the parent class, and another class will be the child class. And whatever the method and properties that you have defined in your parent class, all are available to the child class, right? That is nothing but we are extending the functionality of a parent class to the child class, right? So the child class will have all the properties, all the behavior, all the functions that you declared in the parent class, and using the child class instance or using the child class object, you can access all those things, right? So if you take the example, suppose, okay, let's create another class. Suppose this is your public UBLIC public class. Suppose this is example 1, this is parent, right? And inside this parent class, I'm declaring some variable, let's say public string name. So public integer ID, and here I'm declaring one method public void display, right? So this is what I'm declaring here, right? Now I'm creating another class. I'm creating another class public class child, right? So here I'm inheriting this class from the parent class. To inherit, you need to use column. We'll discuss this syntax, everything in detail. And here I'm declaring some of the methods. So I'm not declaring these two things. I'm declaring a display two, right? So now, if you create the child class instance, okay, let me remove this. If you create the child obj, right? If you create the child class instance, then using the child class instance, we can also access this parent class member. Now, if you write obj dot, then you will see that name, ID, and display along with display two. See, obj dot. See, name is available, ID is available, display two is available, and where is that display method? Yeah, display is also available. This one display. Yes or no? So this is nothing but inheritance. Inheritance means whatever properties, whatever member you have defined in your parent class, all are available inside the child class. This class is called as parent class or super class or base class. This is going to be called as child class or subclass, right? Or subclass, child class, and you can say, or what, derived class, right? So this is nothing but inheritance. Polymorphism means, I'm just giving the definition, right? We'll discuss all these things in detail. Polymorphism means it is basically a combination of two words. One is poly and another is morpheme. Right? Poly means many and morpheme means behavior or phases. So polymorphism means the ability to take more than one form, right? Technically, we can say that the same functional operator will show different behaviors by taking different types of values or with a different number of values. It's called polymorphism, right? We'll discuss polymorphism in detail, but for now, if you want to understand polymorphism, so what I can show you is, suppose this is one class, right? Suppose this is one class called a calculator, and in this class, I'm saying public void add method, and this add method taking two parameters, integer x comma integer y, right? And this is x comma y. So what I'm doing, I'm creating three different, right? So this is integer x, y, and here integer z, right? And here I'm writing string x and a string y, right? Now you can see here I'm having one class, and inside this class I'm declaring three methods, but these three methods are having the same name. Now from the main method, so what I'm going to do, I'm creating an instance of the calculator class, and when I invoke the method, then you will see that does it showing me three different versions of add method? It is showing me only one add method. Why? Because inside the class we have defined three methods, but the user of this class is expecting that this is a single add method which can take a different number of the type of parameter. Now, to prove this, what I can do is I am writing add. So when I type add, you can see this add method is overloaded three times. One of the version is taking two parameters, and if you click on this down arrow, right, so it is saying string x and y, and another method taking three different parameters. That means whenever the number and the type of parameters are changed, the behavior is also going to be changed, right? So whatever functionality you have written inside this method, it will work when you pass two parameters, right? But the behavior is changed when you pass three parameters. So this method is not going to change. Instead, this method is going to be changed. And when you type different types of parameter like I and by, then again a different method is going to be invoked. That means when the type number of parameters are changed, the behavior of the function is going to be changed. That means the functionality is going to be changed when the parameters are going to be changed. So depending upon the input, it is going to give you the output. This is nothing but your polymorphism, right? We'll discuss. So whatever we are discussing now, encapsulation, abstraction, polymorphism, and inheritance, everything we will discuss in detail, right? Now, why do we need object-oriented programming? Means already we have discussed, if you want to achieve these things, if you want to achieve reusability, extensibility, simplicity, and maintainability, then you need to go for object-oriented programming concepts, right? Then you might be one question, sir, what are object? See, all the living and non-living things that you can see and touch in the world are objects. So real world objects such as person, animals, bike, computer, etc. can be developed in programming language using OOPS concept, right? Then these are some of the interview question. Why do we need real world objects in a project? We need real world object in a project because real world objects are part of our business, right? As we are developing software for automating the business, we must have to create the business related real world entities or real world objects in our project. See, suppose you are developing one application for a bank. Then for bank, what are the entities used inside the bank system, right? In the bank system, we are using customer, manager, clerk, right? We have some computer, printer, chair, table, right? So amount, money, transfer, deposit, everything will be considered as one object along with the bank object. So if we want to develop a banking application, then we also have to develop all these entities as object in our application. So technically, we call this object as a business object, right? Then what type of programming language come under the OOPS system? The programming languages which implement all the four principles provided by OOPS are called object-oriented programming languages. What are these four principles? Encapsulation, inheritance, polymorphism, and abstraction. The programming language which support these four principles is called object-oriented programming languages. Example, Java, CSharp, and C++, etc. Now, some of the points that you need to remember, or you can say the summary of this session. Object-oriented programming principle or concept in CSharp are a design principle that suggest how we should develop a program so that we can reuse it from other layers of the project effectively with a high scalability, right? So basically, this OOPS concept provides us some suggestions how we should develop our application, right? So how should we develop our application so that we can effectively reuse the functionality, we can effectively extend the functionality, we can effectively simplify the functionality, we can effectively maintain the application code, right? Along with high scalability, right? So if you want to achieve this, then you need to develop the application by following the OOPS concept. And what do we mean by scalability, right? We need to understand this term. Scalability means we have to develop the project in such a way that it should accept future changes without doing major changes in the project. See, in most of the time, I have seen the day one we started developing one application, and when we deliver the project for the client, it completely changed. The requirement is completely changed. The functionality is completely changed, right? That means what? Now we need to design the software in such a way that in later stages, in the future, if some requirement are come, if some changes are come, then it should adapt very effectively, right? With minimal, with small changes in our application code, we should adapt those changes, right? And how we can do this? If we follow the OOPS concept, then we can achieve this very easily, right? So scalability is achieved. And how we can achieve scalability? We can achieve scalability when we develop the software component in loosely coupled manner. So we'll discuss what is loosely coupled, what is tightly coupled, right? What are the problems you will face if you are developing the application using a loosely coupled, right? So there is a concept called a dependency injection design pattern. In the dependency injection design pattern, I will show you what is tightly coupled, what is loosely coupled, right? Then I will show you what is the problem we are facing if we are developing the application in a tightly coupled manner, and how we can overcome such problems by using a loosely coupled manner. That is, if we are developing the application using interface, then how we can achieve the loosely coupled, right? So at that time, I will explain. Dependency injection design pattern is there as part of the syllabus. We will discuss that. Then we should develop the project with scalability as there is a growth in the business. See, whenever we start developing suppose I am one of the client and I want to start my business and I want you to develop a project for my business. So on the day one, as per my requirement, I give you the documentation, I give you the requirement. This is my requirement. I need a software for these things. Then you will develop the software according to the requirement which I provided in the initial stage. But my business grows. My business in first month it do some kind of a business, but going further the business grows, right? So once the business grow, that means we need to add more functionality. Yes or no? And that functionality should be accepted, right? That functionality should be adapted to the software with minimal changes in your application, because this is the main objective, right? When developing the application is not that difficult, but maintaining the application is difficult. Maintaining the changes, future changes is difficult, right? If anyone working any real-time experience, anybody have, then they know the future changes. Suppose you are developing one application, every month, every quarter, you might be getting some requirement. Yeah, the client saying we need to implement this one. The client saying we have to enhance this one. So enhancement is the thing which is a constant in industry. So if you are developing an application, you need to keep that thing in your mind. So if tomorrow some changes comes, then I should do the changes with the minimum changes in my existing code. Right? As a developer, we must remember that initial stage of business, customer never makes a significant investment. As the business grows, customer increase investment according to the growing new requirement and also added to the project. To add those new requirements, we should not design the project entirely, right? When the new requirement come, we should not design the project entirely. So we need to project from the initial stage, from the beginning, so that whenever the new changes come, it should adapted to my software, to my code easily. That is what the main objective of OOPS concept. If you are following OOPS concept, then you will achieve all these things. Is that clear?
Yes.
Okay. Anybody having any questions? So I have targeted to cover the class and object concept also today, but there is no time. So see if anybody having any issue related to this OOPS concept, how we develop application, how we see the application, at what scenario we need to go for modular programming, at what scenario we need to go for object-oriented programming. If we are developing the object-oriented programming, then what we need to think about the system. We need to think the system as a collection of functions. If we are developing the application by adopting the object orientation, then we need to think the system as a collection of objects, and each object having functions, but we need to think in terms of an object, right? What are the problems we are facing in modular programming, right? And how we can overcome such problems using object orientation programming. See, in modular programming, we are basically having 4 issues. What are the issues? Reusability, extensibility, simplicity, and maintainability, right? And if you want to overcome this problem, then you need to go for OOPS concept. So reusability issue you can identify using class object. Simplicity you can achieve using these 3 things. Extensibility you can achieve using these 3. And once you achieve this thing, then maintaining your application code becomes easier. Then we discuss what are the OOPS concept, right? So basically, OOPS provide 4 concepts: encapsulation, inheritance, polymorphism, and abstraction. Don't consider class and object as OOPS concept. Class and objects are basically used to implement the OOPS concept, right? As part of an object, what we are going to define? We can define data and function. Data is the primary thing or most important thing, and function is the secondary thing. And function operate on the data, right? That we discussed. Then we discussed the definition of abstraction and encapsulation. And we have not discussed any example related to abstraction and encapsulation in the respective chapter. We will discuss these things in detail. And at that time, you will have a very good understanding regarding what is abstraction and encapsulation, what is inheritance and polymorphism, all these things. Then we discussed why we need object-oriented programming because of these 4 things, right? And why do we need real world object? Because of this, because we are developing the application for business. So the business related entities should be developed in our project, right? And what are the programming languages comes under OOPS concept? The programming language which support the 4 principles provided by OOPS are comes under the OOPS programming language. And this is the main objective point or note that you need to develop. If you are developing using OOPS concept, these are the things